CiA webinar.
Now it's in progress.
Okay.
Please.
Welcome to the CiA webinar titled CiA Profiles Mapped to J1939. This webinar will be presented by Oskar Kaplun and myself, Holger Zeltwanger. So we're looking for the agenda, and we will give you a short introduction to the topic, then some background information on CiA. We will have some specifications discussed like CiA 510, and then we go to the main topic, which is in this webinar, the profiles mapped to SAE J1939. We'll also have some detailed information on the CAM11 and CAM21 parameter groups in ISO 11992 and how they use them or will use them. And then we will have a summary and some CiA office contacts. And at the end, we will have also a question and answer session, which will be not recorded. Starting with myself, I'm an electronic engineer and a technical journalist since many years. I initiated the foundation of the CiA organization, and I'm a member of the board of directors since 1992. Additionally, I'm active in many standardization bodies, including ISO, IEC, DIN, and SAE. So I'm an active member in the J1939 committees and its associated task forces. Oskar, perhaps you will briefly introduce yourself. Oskar?
So that was a brief issue. Now it's resolved. My name is Oskar Kaplun. I'm electrical engineer, and I'm working at CiA Automation and supervise several technical groups. We work together designing specification for CAN-based protocols and also for application-based, CAN-based application such as CANopen, CANopenFT, and also our application profile and device profiles. As you may recall it from title our today's webinar. I'm also doing tests. I'm test engineer at CiA Automation for CANopen and CANopenFT device conformance and also their interoperability. Beyond that is I'm also expert in our standardization efforts for CANopen drives. Thank you. I give the microphone again to Holger.
Yeah, thank you, Oskar. So as you know, the CiA organization is promoting CAN technology, and we are also developing the CANopen higher layer protocols, and we are also committed to support any other standardized CAN-based higher layer protocols like J1939. As you may know, both of them have been developed in the early or the mid of the 90s. And they went different directions. And in the meantime, we have something which is then in cooperation. So we have already standardized and specified some CANopen services on J1939 so that you can make use of the CiA profiles also in J1939. We will go into that much in more detail to that. Just briefly, you know that we are very technical driven. Most of our work is in regard to CiA specifications and other standards like J1939, like those from other standardization bodies. Let's go into some details, and Oskar will introduce you in the OC reference model and how this all works together. And then we will go to the more technical, in-depth solutions, what CiA can provide and how we can cooperate with J1939 networks. Oskar, it's your turn. Yeah.
Well, we shall start straight into the topic, as it is mapping of CANopen profiles into J1939. For that, you need to know what are the profiles, J1939 and CANopen, and what it's all about. Unless, of course, some of you have already experience with CANopen, J1939, and know a thing about communication system. So that is necessary a little bit to know how this whole things works. It is all actually goes around the ISO OSI communication reference model, where embedded systems and devices are designed upon. The typical ISO-OSI comprised the 7 layers, as is provided in this picture. For deeply embedded or just embedded systems such as CANopen or J1939 in their respective application fields, not all the layers are needed to be implemented in software and hardware. The most, or in roughly, physical layer is the layer 1, data link layer, and the application layer, mostly sufficient since there are no human interaction in there required, and some other key things such as no routing is necessary because we're talking in this case about a CAN system broadcast communication model of the CAN protocol. So physical layer and data link layer, they're both CANopen and J1939 are, if not identical, using the very same protocols, which are also standardized. At least data link layer as CAN is standardized in ISO 11891. And so the only things which is here marked with a green circle or marked with a green color around that to point out what is actually we are talking about, we will talk about, what is the point of our interest. And the idea is actually the mapping of CANopen into J1939. Although there is a possibility and necessity, it goes also the other way around. But we concentrate in the first place on the mapping of CANopen to J1939. There is application layer. CANopen is an application layer. It uses CAN as a data link layer and physical layer, the same as J1939 uses them both, physical and data link layer, with some certain distinguishment. But the application layer, the communication profiles and communication protocols are completely different, although they use both CAN. So the issue was, actually, we do not design something just for fun. It was a request of our members. This were member-based organization. Our member who designed CANopen devices, J1939 devices, and they actually needed for their J1939 trucks mounted and other vehicle-based systems that they have data from CANopen-based applications, which are already a part of the vehicle, that they have an opportunity to communicate into J1939 network. So just look into the things CANopen and J1939 in the application offers. In this point, it is wise to mention, as it is marked in this slide, there are several CAN technologies now available. The classic CAN called CAN-CC, and the next one, CAN-FD. CAN-FD offers more than 8 bytes of data, actually 64 data bytes for process data payload, and also can be transmitted at a much higher speed than a classic CAN, as called CAN-CC, meaning not only 1 megabit, but up to 5 megabit. Especially it has a specification in J1939, which covers exactly the 5 megabit and 2 megabit bit rates of CAN-FD. For the moment, it doesn't affect application, because application in itself, such as CANopen, can be used not only on CAN, whereas J1939 uses CAN as it is data link layer. But there's a topic for possibly another webinar of ours. For now, it is important to know that the application layer is completely different and the mapping of the data between them is not easy possible. It required actually a look into this and providing some adaptation that could be to reuse the data between the both application layers. Now, the topic of the webinar was also profiles. What are the profiles? While application standardizes how the data is represented and the protocols needed to transmit this data, receive this data, the profile standardize actually the application type used. For example, we have municipal vehicle application, or maybe this is crane-mounted or agricultural vehicles. That is where the profiles come up. They are not the part of ISO-OSI model, but they are additional standardized representations of every specific application which uses certain application layer. So in CANopen, for example, we have back to the point of different CAN technologies. We have one specification, one application layer for classic CAN, one application layer for CAN FD. In J1939, it is a little bit different, but there are this specification which marked actually a data link layer and for FD and classic, such as J1939-21 and 22, which actually represent more or less the application layer, and clearly, although they assigned as a data link layer. The application layer of J1939-71 describes also the communication and representation of data, which is clearly defines the application layer in itself. So CANopen has its own protocols for broadcast, for unicast, for configuration, and so on. In contrast to J1939, which has only few profiles, such as one for agriculture and one for special vehicles, CANopen has plenty of those. They are put in specification series 400, which you can see on the left side. Specification series 300, there are various additional functionalities of CANopen. There is also one key difference between them, but that is what I would like to go into the next slide. Thank you, Holger. So what is very specific, which still prevents us just to have using transparent gateway, in-vehicle gateway, to push the data from one network into another? That is, the data is represented in CANopen in the code object dictionary. This is database of indexes and sub-indexes. I can assign a parameter to them. In contrast to this, J1939 doesn't have this one. It relies on a fixed entries for the process data, which are hardwired into the frame used in J1939. This is one thing. So the object dictionary in CANopen is constructed with index and subindex, and there could be very many of them. Just for information, for more details, you can look into our specification, basic specification net, and you can represent in general multiple applications in there with various parameters for configuration. This one is not provided in J1939, but is also not needed there for the current usage. Communication, from communication point of view, communication profile protocols, CANopen has used various one. This is actually a complete network management embedded in there. There are also CAN typical broadcast communication for process data. There is also service protocols just for point-to-point communication between the devices, for configuring them, and so on. J1939 is actually fixed hardwired configured. The configuration of the device is not possible. We have to return this to the manufacturer and to use special tools to do so. In CANopen, it is more flexible. This is about the difference in itself. Then to do so, actually, you need to use some kind of adapter between the two technologies to make process data available to the corresponding network in itself. So please, in the next slide, we will talk about this mapping, this adaptation of the data, which can be used in both between CANopen and J1939 networks. For the first, there is, of course, for most of the cases, there is no way around a gateway, because gateway works between different application layers. So gateway is a must-have. The question is how much of both should be in the gateway itself. So, as I said, J1939 is fixed configured. Things are hardwired. They are fixed names for the process data, and they are fixed sizes of that. In CANopen, you have this stored in the device itself, and you have access with a special tool to this. In order to make available this functionality of various CANopen protocols for the J1939 networks, and know if the data which comes from J1939 network, how can you reconstruct the message for CANopen network using this STO and MC services of CANopen. For that, we have a PG as a parameter group number. We requested it a long time ago from CiA organization, so they are fixed. This way you can use them for mimicking STO and emergency communication protocol in J1939 networks, and know which message in J1939 was resembled and how can I reconstruct it if it is needed for CANopen network. Holger explains in a few minutes in the next slide about this, but for the moment I would like to point other opportunities in there. There is a possibility straight to have a device, as on request from our members, that a device which our members designed previously only in CAN interface, it could be also designed with J1939 interface. How we could do so? The same way we request in a digital annex of CiA in J1939, exactly the process data, since nothing more is required in J1939 devices in itself. For that, the example I will explain later on for just devices such as encoder and accelerometer. Another thing, though, just a second, back to this slide, shortly finished. As I said, the gateway is necessary in this in any ways because we are interacting with in-vehicle networks. It is anyways here, and we need to have CANopen and J1939 network. So we have our CANopen profiles, which were designed for very specific applications, for truck gateway and for municipal vehicles such as CleanOpen. They were designed in CANopen, and internally in the device, of course, there are J1939 networks. Interaction with them would require also to know the PGNs and assign the PGNs to very critical services and process data, which may be needed from CanOpen into this one. But we discuss this in the next. So then please, Holger explains you about these basic interaction protocols of CanOpen.
So the from Oscar mentioned CAM11, CAM21, and CEM, CanOpen Emergency Message Parameter Groups, are specified in the digital annex, and they reference to the CiA 510 document. In this document, we specify the parameter groups in detail. So the CAM11 parameter group is initiated in one of the ECUs and tunnels, so to say, the SDO request service via the J1939 network. It is not transmitted periodically. It is just on event, driven by an event in the application. The 8-byte payload of this parameter group implements the SDO read and write protocols as specified in CiA 301. There's a dedicated PGN assigned by SIE for this parameter group, and this is a point-to-point communication, always indicating the destination by means of an 8-bit destination address. The default priority is 7 hex, so it is a very low power message because it's mainly used for configuration and for a diagnostic. Of course, we SDOs in confirmed service. We need also then the response from the addressed devices by the request service. And this is the CAM21 parameter group, and this is transmitted to the addressed J1939 device, which has sent the request, and the payload of 8 bytes implement the SDO response protocol, including the abort protocol as specified in CiA 301. So you have now the same capability as in CanOpen on J1939 to implement a CanOpen dictionary and to access all the parameters by means of an 16-bit index and an 8-bit subindex. Also, there's an assigned and standardized parameter group number plus the digital the destination address. The priority is also very low. The CanOpen emergency message parameter group is transmitted in broadcast. So you inform all the other nodes or ECUs in the network that you have detected a problem. The 8-byte payload implements the emergency protocol as specified in CiA 301. So they have a generic mechanism to inform all other nodes with a very high priority about that something has occurred in your ECU, which is not normal and which you like to report to the others. The PDOs can be mapped to PGs. This means very simple that you take the content of the 8-byte PDOs and transmit them via parameter groups, which are assigned to different CiA profiles, and there we have requested parameter group numbers, and Oscar will show later a detailed example for the encoder profile. So this means we can completely use the same mechanism as in CanOpen, including the object dictionary, including the SDO communication for configuration and diagnostic purposes. We can also transmit emergency messages and, of course, the normal PDOs as PGs. They are just mapped one-to-one. The benefit for the device manufacturers, they can use the application software from their CanOpen devices and map them directly to the application layer of the J1939. This is a very simple example where you can reuse your software and don't have to invent something new. I hand over back to Oscar, so he will continue with the next information about the J9, the 406 and 410 profiles, how they can be used on J1939. Oscar.
Thank you, Holger. So for the next slide is an example what we have. I have combined two profiles. The idea behind was, as Holger said, to provide identical process data in each of the network. Since our members design CanOpen devices, the only thing in these CanOpen devices may be the process values needed clearly in J1939. So you can go straight up with your existing CanOpen device, and what you can do in there, or let's say with the software in itself and J1939 protocol, what you just needed is what we have already registered, the parameter group. So you can embed exactly the parameter group number for the process data into your encoder or inclinometer. We call them like this. Then you just, instead of CanOpen interface, you can have your J1939 interface. This is direct approach. It was designed, of course, for this case specifically. While just to mention that 406-J is our specification for encoders. Now with J1939, with CanOpen mapping to J1939. CiA 410 is the inclinometer, the same thing for inclinometer. So here's necessary to say that we have also structures designed in there exactly to fit J1939 structured message. And in generally, you don't need to have any addition from CanOpen into these encoders. You may use them, but it could be designed just as an encoder. You just know that if you have different encoders in different networks, of course, with the corresponding interface, their process data will be the same. This is the key thing here. Of course, if you would like to have, for such a simple device, it's not necessary, but if you would like to have the data mirrored in the other network, then what you need is also to possibly to have this using the communication service, as this came 11 and 21 for these PGs that transfer this data into the gateway itself. There is not necessary to put this, or possibly there is no use case to use it on CanOpen side, but just provide it in a gateway for further processing. The data coming from the CanOpen network can be also hanging as the double or a redundancy devices, just as CAN network and J1939, but they deliver should deliver the very same value. The only thing I've mentioned here, CanOpen safety is supported, a special way of machinery as functional safety we standardized by us, which we have applied for our CanOpen version of 406. Of course, J1939 has its own safety, and this is CanOpen safety is not mirrored in there. It is not supported in this case. It's just inclinometer and encoder has just provided their necessary process value. In the next slide, we look into the structure of those, just as an example. I've given this probably only just for 406. Now you see on a colored table with some green marks, the parameter group numbers were requested at CiA. We registered, they are registered, of course, and you can immediately use them so far you are getting the specification from us in your encoder, which you would like to cell with J1939 interface. Beyond just a list of parameter group numbers, there's also an example which is exemplary information in here. This is exactly like that, is mapped into J1939 message for the encoder for encoder position value in the corresponding in a corresponding J1939 message. And the second table you see with attribute and value lists the corresponding J1939 message format, such as PDO format field, PDO specific field, default priority, data page, and so on. This is all already here, so you can use this data and map this straight fixed design into your J1939 encoder. For the moment, in this case, you don't need yet object dictionary or service communication, just it could work like itself in there. Since the parameter position value is only 32-bit, we have still some place reserved. We have reserved for important reason, so the manufacturers do not put there something else. Thus would be completely identical with what we have with a very corresponding PDO in case of CANopen encoder with this position value. So then in the next slide, we have, I think the example for CiA 410 in clinometer is not necessary. It is designed the very same, so you could design such encoders on inclinometer straight with J1939 interface, and all the data you needed for that is already provided. Now we go to the more interesting things called application profiles. Since J1939 extensively used in truck and trailers, heavy vehicle, also in agriculture technique, now agriculture and so on. We have CANopen-based application for truck gateways where we provide the information, what the specification, what the gateway shall have inside. The list of all begins on J1939 side. And of course, since there are several application, several components of the truck and trailer, at certain point earlier were designed and are designed now with the making sense with CANopen data. It makes sense to have put them in a gateway and provide not a transparent, but a transition table or transposing table where you have the data, where the CANopen-based body application units located, and their corresponding pendants on the other side in J1939 networks, and possibly the place where this data in from CANopen side, from body application, goes into the truck-specific network and truck-specific J1939 device and a network. For that, we have several parts of this application profile. We list parameters for truck and trailer, for brake, if I'm not mistaken. Then we have also a part for gateway in itself, what the gateway has to as parameter for PG-based list. And then finally, there should be also at certain point an isobus PGs located in there, so we can transpose and exchange the data between CANopen and J1939 network in this truck gateway system. So the next slide, unless of course Holger has some additional thoughts I've missed to say about 413?
No, not yet.
Then we come to another application we have for municipal vehicles. It has their certain structure, and from the start it was designed with CanOpen in mind. There is an object dictionary, CanOpen object dictionary in there. There are plenty of entities in there we call virtual devices for every aspect of municipal vehicle. There is a bin control, weighing control of this. So every ECU part responsible in the vehicle for certain task of rubbish collection and some similar task in there. They assigned their own names, their identifier, and parameters in CanOpen base, CanOpen object dictionary. And of course, there are no such units and description on the J1939 network. J1939 network, there is necessary to have access to certain ECUs, and that is necessary to connect several so-called virtual device information and process data with J1939 network, using, of course, the gateway. Now in the picture, you see the structure from the CanOpen point of view. This is on the CanOpen network illustrated here. You just need to know and to take from this that is a complex structure designed in the network where there's multiple virtual entities holding data from very various physical entities producing certain information, and this data is held in these virtual devices, and this information, given it is a gateway to J1939 on CanOpen side, it contains this data in there, and it is accessible for the certain reasons if it is necessary for the certain tasks for J1939 networks. What I've missed to tell additionally for diagnostic also in 413 networks, there is of course more what CanOpen can do in this case. The complete, since this is a complete network management, we can store also the complete application interconnection in there. So how these virtual devices are working, they are called, the things are called actually network variables. They hold the process image. For example, there will be in truck gateway complete image where which data should do what. The same applies also for municipal vehicle. In such a gateway, the network variables can be used if we even use the fleet management and need to share the data and know what is happening among several rubbish collector devices, where they are currently located, and if their weight value are correctly, they are collected also and measured the values correctly, and if there were some issues underway and so on. That is why CanOpen from this point of view is much larger and has much more additional things, additional opportunities to see also in diagnostics. Although, again, it says each of those networks does execute there and works in a very specific application segments. They fulfill their need, and do not need to be identical, but now we have also the interaction between them, and they could be mapped into one another. So in the next slide, whatever that might be.
So just to add a few things and to clarify, the CIA 422 profile has not been mapped yet to J1939, but we can do it very easily by means of requesting for the related parameter groups then, or the PDO's parameter group numbers from CiA. And we implement then in the devices a CanOpen dictionary. And then we have access to configure the different virtual devices by means of SDO services mapped to CAM11 and CAM21. And we also can have the emergency messages. So you have the entire or complete functionality of CanOpen then available on the J1939 network, and we can configure, we can communicate with the virtual devices as in CanOpen. So there's a request which you have as a user, which profile should be mapped, and then we just need to request parameter group numbers for the PDO related parameter groups to make it clear. But we can do more. And I give you an example from a J1939 network, which we have developed more than 20 years ago. You see it here that we have a J1939 based communication point to point between truck and trailer, so between a towing vehicle and to be a towed vehicle, to be very precise. And we can have up to 4 more towed vehicles, so that we have in total 4 segments. And then we can request, for example, braking behavior. We can switch on and switch off lights. We can have a lot of things between these vehicles. However, there is the first segment has a lot of messages to transmit, because it has to forward all the PGs for the additional towed vehicles. So this is, so to say, a bottleneck. You see, you can't send all the messages, perhaps if you have up to 4 or 5 trailers connected to the vehicle. And of course, you get also have a response requested, and then you need to respond. So this first segment is highly loaded at the end. And with J1939, we have no chance to manage that because we can't configure things. If we would use then CanOpen mechanisms like the SDO communication, and then we can switch off and on some of the functionality of PGs. So the EU directive regulates this by means of mandatory parameter groups. Not all those parameter groups which are specified in ISO 11992 are mandatory, only a few of them. But if you have a high sophisticated trailer, then you have a lot of them. And if you connect more than 1 or 2 or 3, then you will have a bus load issue on the first segment. So this means we also limit it to 125 kilobits because of the physical layer. And we can't chain this because all the trailers should be interoperable between all trucks. So we can't have different bit rates there. And of course, at the end, we have a not acceptable delays of parameter groups in the first segment, and then some functions may not be performed properly. To overcome this, the bus load should be limited by means of enabling and disabling optional PGs, meaning optional functions. In the responsible working group in ISO, we have decided to use the CAM11 and the CAM21 parameter groups to configure the parameter groups according to the PDO parameter sets. And you know that we have in CanOpen a PDO communication parameter set. And in this parameter set, in the first subindex, there is given the identifier which we transmit this, this parameter group. And we have also a bit there where we can enable or disable the transmission of this parameter group. So what we just need to do, we need to specify in the range of 1800 hexadecimal to 19FF hexadecimal and assign the PGs to PDOs, to PDO parameter sets. And then we just can disable or enable things. In default or by default, we enable only the mandatory PGs requested by the EU directives. And depending on the number of trailers and the functionality of optional things which are implemented, then we can enable, or the truck can enable additional functionality, meaning additional PGs. And this is very simple. And to avoid that you are configuring too much, there is not implemented the possibility to change the identifier. We also cannot change the mapping. This would be theoretically possible, but in this application, we are not doing so because we don't want that the driver of a truck should start to configure things, and then nothing is more working. So this gives you an indication how we can make use of CANopen functionality and features in a J1939 environment. And this is not only that we can map classic CiA device profiles, we also can map, if requested, application profiles, and we can use for purely J1939 functionality also the CANopen benefits regarding configuration of different PGs, enable them, disable them. We could also change the priority. We could change other things as well if this is desired. So this is up to the standardization bodies. How to use CANopen provides all these flexibility. Just coming to the more or less last slide. So you have seen that CiA 510 specifies the mapping of SDO and emergency services to J1939 parameter groups. So this means we have in general, we can use the same functionality of CANopen and all the benefits of flexibility on J1939 networks. And there are specified J1939 parameter groups mapping of the CiA 406 and CiA 410 process data. And we hope that there will be more requests on that and that other profiles of CiA will also be provide a mapping to J1939. The mapping of CiA profiles enables the device designer to reuse CANopen profile software for J1939 devices. This is a very important issue because you don't have to change your already existing CANopen product regarding the application. You just have to provide another application layer, another protocol stack, but the functionality and which you have already implemented in an encoder for CANopen is the same than in J1939. And the CAM11 and CAM21 parameter groups, they allow the mapping of SDO services and can be used to configure the J1939 device in the same manner as CANopen devices. So you can change the mapping to the PDOs. You can change the accuracy or or anything what is configurable in the profiles. And as I said, the CAM11 and CAM21 parameter groups mapping the SDO services are intended to be used in the next generation of the ISO 11992 parameter groups. You have seen that there is also a specification for configurable parameter groups in J1939 specified, but nobody is using it, there was not the smart thing like a CANopen dictionary. This is a little bit complicated to implement, and the straightforward solution as CANopen provides is much more benefitable for the implementer and for the user. So this is the summary of that what we have provided for the how you can use CanOpen mechanisms on J1939. Just give you a few chances to have contact. You find a lot of on our websites, of course, on more information. And if you want to be in direct contact, then you can have emails to different addresses in CiA. For technical group participation in, you write to secretary. For technical questions, you write to service. For education service, you write to events. And if you want to submit press releases or articles, you write to PR. And if you don't know to whom you write to headquarters, and your request will be automatically forwarded to those people who are responsible in the CiA organization. I think we should stop recording, Oscar, if you can do so, so that we can come to the question and answer session.